Hi, good evening, everyone. So, I am Shubhanu. So, I am a PhD scholar at IIT Delhi. So, today we'll be starting our session for the. So, this today is the last live session of this course. Since CS108 operating system fundamentals. Okay. So, today we'll be looking in the virtual memory and file systems. So, just give me a second. I'll be sharing my screen very soon. Hi, there will be class on 18th October. 18th October, no, there will be no class. Yeah, there will be no class after this, I think. So maybe there can be a summary session. So it may happen. Okay, yes. Summary class will be happen. Will I will conduct a summary class on 18th of October. Okay. Okay. So today is 12. Uh, So can you please start by solving this question? अंकल जी डब्बा फेंक दीजिए डब्बा फेंक दीजिए Okay, so the right answer for this will be executing the files within the directory. Okay, so can you solve the next question? ये हो गया है, ये हो गया है, हाँ. Okay, so the bitmap technique is used for in which file system? So this is used for to keep track of the available and allocated allocated disk blocks in the system, right? Okay. So what is the disk pattern? So okay. So do you know that how the file system or file is look like? So that's the main question. So file system is the software which provides the mechanism for online storage and access to file content, including data in the program. So it deals with the following issues like file structure to allocate disk space, recovering free space, to track the locations of the data, interface, interact with other parts of the operating system in secondary storage. Okay, so this bitmap technique is used in the file system to keep track of available and allocated disk blocks or sectors. Okay, so can you tell me that without this bitmap, what are the other techniques? So we have two things like to keep track of free space. This is called free space management. Okay, so for free space management, we have bit vector and we have linked list. Okay, so how do I keep track using this linked list? So suppose this is your memory. In linked list, every block will be linked towards the other, linked with the other block. Okay, so this is how it started and this is how it ends. So linked list basically link together the free disk blocks, keeping a pointer to the first free block in a special location, this one, and on the disk and catching it in the memory. Okay, this is how this. So suppose there is a free block. So what I do that. So this is the free block after this block. This is the free block after this block. This is the free block after this block. So this is how it maintained the free space. It memorized the free space. Okay. And how bitmap does it? So in bitmap technique, it does it with 001. Okay. So this means that this one is a free space. This one is a free space. This one is a free space. Okay. So initially all are one. Initially all bits was one. Okay, so whenever you use it you make it zero, you use it you make it zero, you use it you make it zero. This is how it happens. Now this is the important question, like these are the question is fine, but this question about the input output scheduling. So these are the main important topics of these of today's class. So one is FCFS, fast come fast serve, then SSTF, shortest stick time fast, and we have a scan algorithm or elevator algorithm, and C scan and look. Okay, we will be looking towards all the algorithm one by one. Okay. So this algorithm says that suppose that a disk drive has 2000 cylinders, number from 0 to 1999. The drive is currently serving a request on cylinder 143, and previous request was at cylinder 125. The queue of pending requests in FIFO order is 861470. These are the and this is the pending request. Starting head from the current head position, what is the total distance in cylinder that the disk are moves to satisfy all the pending requests for the SSTF task scheduling algorithm. So important things to be noted that this one these are the requests. Okay, and serving a request. So currently it is at 143, and it will end at 130. Okay, and we will be using SSTF disk scheduling algorithm, which is SSTF is basically short. SSTF means shortest seek time first. Okay, so yeah. Okay, so how does it work? Okay, like SJF. So last day we have implemented the shortest job first. Okay, like SJ, here we select the disk input output request that requires the used movement of the disk arm from its current position regardless of direction. Okay, so maybe it is possible that okay, so this is our algorithm. So what can we do that? We first try the simplest one, which is FCFS. Okay, so you all know the meaning of FCFS. Okay, so this is the simplest one to perform. So there is no ordering, okay, and no starvation. Starvation means waiting. Okay, like every request will be served. Okay, so the example is given like so 23, 89, 132, 42. Yes, yes, yes. ओ तुम ये पहले नहीं बताओगे? Sorry, sorry. So what I was saying, I was moved from the first. So it was that yeah. So the question was about SSTF, shortest sick time fast. So shortest sick time first I will come later. But first one is that our FCFS, which is fast come fast. Sorry. Okay. Okay. So we have a so first come first serve is the simplest one, which is the input output scheduling for the input output scheduling algorithm. So we have a request like 23, 89, 133, 132, 42, and 187. Okay, so what how I will solve my question? I will be how many are there? Six. Okay, so I will be starting from okay the disk you so disk head initial 100. Okay, so this initially this is situated at 100, 100 position. Okay, so find out the total seek time. Okay, so how I solve that? I will write like this. Okay, so how many line you will draw? You will draw total number of given numbers your request. So these are your requests. Okay, and plus one because your head will be pointing to some number also. So you will be drawing total the request plus one. Okay, for the initial one. So 23, 89, 132. Oh, okay. So I have missed something. So we will draw in in an increasing order. Okay. So 42 will come here. 89 will come here, 100 will come here, 132 will be here, 187 will be here. Okay, so how I will calculate? So it is given that my head is initially at 100 position. So I am at 100. So then first come parcel. So first, which one is coming? 23 is coming. Okay, so I am at this position. Okay, so I'll be going to 23. Okay, fine. So, so what is the time needed from here to here? So you need 100 minus 23. So which is 77, right? Okay. Now what you will do? Now you are at 89. Okay. So then you will going from 89. You will 23. You will go to 89. Okay. So what is the sick time? Sick time mean what is the time you need from going 23 to 89, which is 89 minus 23, which is 66. Okay. Fine. Now what will happen? From 89 you will be going to 132. Okay, so 132 is here. So what is the time you need 43. 43. Okay, 43. Why? 132 minus 89 is equal to 43. Okay, then what will you will do? Then we'll be going to 42. So where is your 42? Here is your 42. Okay, so how much time do you need? You need 90. Okay, then again we will be going to 42 to 187. 42 to 187. Okay, so how much time do you need? You need 187 minus 42, which is 145. 145. Are you getting it? So okay, so total sick time, what are the total sick time? Total sick time is equal to 77 plus 66 plus 43 plus 90 plus 145. which is 420. Okay, so I think you have got that how fast our fast service going. The first 23 coming, so we are going to 23. 18, then 89, 132, 42, 187. Right? This is how it is happening. Okay, like this. Got it? Okay. So okay, now we will be seeing the SSTF. So SSTF had some disadvantages. Okay, first we will be seeing. Okay, so how SSTF is implemented? So we'll be implementing the SSTF with an example. Okay, so using the same example, 2389. So what are our requests? Requests are 23, 89, 132, 187, and initially our head was pointing 200. Okay, so we will be creating the block lines first. How many lines? How many numbers are there? Okay, there are six numbers: 4, 5, and 6. Right? So yeah. So how I'll be writing? I'll be writing like 23, 42, 89, 100, 132, and 187. Okay. So I'll be starting from 100, right? Then where I'll go? I'll go to so the algorithm is like shortest seek time first. So what is the shortest seek time from 100 to I will be going to the 89. Okay, because you see from 100 to 89 it is only I have two option here. Okay, I have two option with this is 11 and this is 43. Okay, so 43 is the longest, so I will not be choosing this one. Got it? So this is my option. Then what I'll do? Then I'll be going to from 89. How many options I have? From 89, I have 42. I can go to 42. Okay, and I can go to 132 also. Okay, see here that if I go to 42, then I have 47. Okay, and if I go to 132, I need only 43. So though you can see that it is two stick away, but it is just one stick away. Though I will not be choosing it because 47 is the longest one. Got it? So I'll be going here, right? Yeah. So from 43 which option I can choose. I can either go to 187. Okay, so 187, or I can go to 42. So I can see that 42 is far away from 182, 187. So that's why I am choosing 187 with seek time 55. 187 minus 132 is yeah, 55. Then where I'll be going? I'll be going to I can see that from here my option is only this one. Okay, so what is the seek time? Seek time is 145, and then from here to here I have seek time is 19. Okay, okay. So you got the algorithm, right? So if you don't understand, please write in the chat box, or you can unmute yourself and say. Yeah. So total sick time will be 19 plus 145 plus 55 plus 43 plus 11. Okay. So which is 273. So you can see that in FCFS we took 421, but here we took 273. Okay, got it. So these are the algorithms. Yeah. So please try to solve this question now. So how many lines you will draw? So see. So can you tell me how many lines you should draw? There are some misleading information like this 125. This is not important to us. I also don't require this. So otherwise, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 requests. Okay. Okay. So I'll write this in an order that from what is the smallest one? Smallest one I can see it is 86. 86. Then I have 130, 130. Yeah. Then I have 143. Yeah. Then I have 913. 913. Then I have 948. Yes. After 948, I have 1022. Okay. Then I have 1022. Then I have 1470. 1470, right? Yeah. Then I have 1750. No, I have 1509, 1750, and 1774. So yes, got it. This is for this one. Okay. So from where I will be starting? I'll be starting from cylinder 143. Okay. So cylinders 143. From here, where I will go? I'll go to 130 only. Okay. Because 1913 is too far away. So this will be 3. So this will be 13. Okay. So then I'll be go to 130. Then I'll be go to 86. Okay. So which is 86 will be, okay, 130 minus 86, it will be 4, 44. Okay. So from 44, so from 86 where I should go? I should go to 913. Okay. Then like this only. This is how I'll serve my request. Okay. Got it? So 13, 44, this is the 827. Okay. Then 35, 76. Then I have 1024. No, so it will be 1024. Okay. Change it to 1024. Okay. So I'm changing 1024. It will be 446. Then I have 39. I have 241. I have 24. Okay. So what is the total sick time? So total sick time will be, you have to just add all of these. Okay, so if you add all of this, you will be getting 1745. So 17. Hi Diksha, can you confirm me if my voice is audible and my screen is visible or not? Yes. So total sick time is 1745. Okay, okay, great. Okay, fine. Okay, so the correct answer is the sick time is defined as the time required by the read write head to move from one track to another. Yeah, you're right. So this is the correct answer. Okay, required by the read write head to move from one track to another track. Okay, great. Okay, so we'll discuss the algorithm scan and look. Okay, so, yeah. So first, I'll be discussing about the algorithm of scan. Okay, so this is also a algorithm for so which is called elevator algorithm. So how this is solved? That or the algorithm says that go from outside to inside. Okay, serving requests and then back from the inside to the outside servicing request. Okay, so the main thing is basically it is saying that you have to go till disk 0. Okay, and coming for it. Okay, so this is the scan algorithm. So we'll be seeing the same example, right? So what was your example? That 23, 89, 132, 42, 187, and starting from 100. Okay, so 1, 2, 3, 4, 5, 6. Fine. Then what I'll do? That I will be and along with that I have to make a additional bar for 0 because algorithm says go from outside to inside servicing requests and then back from the inside to the outside servicing request. So you have to go until till disk 0. So if I have 23, 42, 89, 100, 132, 187. So this is 100. So I will be going, we'll be starting from one side only. Okay. So first we'll be going from outside to inside. So why inside is 0? So it is like this. So disk is like this. So this is the 0th one, 1, 2, 3, 4, and this is the 100 one. Got it? So outside to inside. Okay. So we will be going from here to here. Yeah. Yes. Then here. Then like this. So this is the extra step. Got it? So this is the extra step you have to follow. Then from here you will be going to. So what are the seek time? 11, 47, 19, 23. So this is 132 and this is 55. So total seek time is equal to 287. So basically I'll be adding all of this. So main thing is I will be starting from the initial position. I will be going to 0. Previously, I might be going to 23. Okay, भाई मैं हट जाता हूँ. So previously I was going to 23, but here I'm going to here. Okay. So this is the scan algorithm, right? Okay. So that's why it is called the elevator because I'm starting from here to here. I am elevating, then I am going here to here. Okay, got it. And we have C scan. C scan is basically in C scan. Here C stands for circular. Okay, so the algorithm is same as scan or elevator algorithm, but C scan for circular. Okay, so in C scan, move inwards. Basically, this algorithm says that it will go to zero, like scan algorithm, then go to the last one. Okay, and in question, it will be given that in which direction the arm will be moving. Okay, got it. So now so we'll see the example again. Okay, so our example was 23, 89, 132, 42, 187, and start from 100. Okay, so I will be drawing like this: one, 2, 3, 4, 5, 6. Okay, and in C scan you can see I have just draw these zeros. Okay, but here I have to draw the first one and last one, 0 and last one, 199. Okay, and I'll be writing the middle one, 32 and 187. Okay, so how I will move, my starting position is 100. Okay, so I'll be I'll be moving towards zero side. So like scan only, I'll be going to zero like this. Then I'll be going to the last one. Okay, why I am saying this? So this is the important step that it will go it will go to zero like a scan, then go to the last one. Okay, so this is the key step here. Got it? Okay, then you can see that here we have some requests are left also, like this is left, this is left. Okay, we have 11, we have 11, 47, this is 19, okay, and this is 23, and this is 199, okay, 55, 1, 2, 12. Okay, so what is the total sick time? Total sick time is 366. You can see that you can see this is a very rare thing that there is a big jump. Okay, you can see that there is a big jump of from 199 to 0 to 199. Even if this sick time is 366 only, which is less than our first come first serve, where in our first come first serve you can see that it was 421. Okay, so it was like this only. So first come first serve was like this. Okay, but but here our C scan is even less than the first come first serve. Okay, which is 366 only. Fine. Now I think you got the answer. So is a so it's, so sorry. So this is the correct answer. So scan is the elevator algorithm. Scan is called elevator algorithm, right? So now can you please do this and tell me the answer? अच्छा। हाँ हाँ, निकल जाएगा। नहीं नहीं, वो ये जिस आदमी का है ना, ये 6 महीने में एक बार आता है और ये सब रख के गया है। वो फिका, वो याद भी नहीं है उसको कि वो है। ये भी हमारा नहीं है। ये भी मेरा नहीं है। इसको आप लेंगे? देख ले तो ले जाओ। अच्छा ही होगा, अब थोड़ा साफ करके। और इसका मैं क्या बोलूँ, ये रख के गया है तो फिर वापस ऐसे। ले जाओ ले जाओ। मेरा तो है नहीं। नहीं, टूटा नहीं, सही है। बस साफ करके देना पड़ेगा। हम्म। So are you trying the question? So can you tell me that? So how will you start? So we have to draw the lines first. So how many lines you will be drawing? So yes. So we have 120 cylinders. This is no use. So we have one, two, three, four, five, six, seven, eight, 9, 10, 11, 12, 13, 14, 15, then 16. Starting from what is the total distance? Almost satisfying the pending request. Yeah. You take your time, solve it, then tell me. So yeah, so the correct answer is 442. Yes. So Diksha has written the correct answer, so I am not again writing it. Okay. 80 minus 66. Then from 66 it will go to 12, 15, 12, then 45 to 15. Okay. So yeah, you have written it correctly. So I'm writing that from which direction the disk will follow. So it will start from 80 because 80 is the first location. Then it will move to 66, then 12, then 15, 45, 48, 50, 109, 89, 56, 59, 34, 88, 113, 24, then 22. Yeah, this is the way. Yeah. Okay, so this is the correct answer, 442, right? So can you solve this one? Yeah. So 395. Yeah. C scan for, yeah. So how many, how I will draw for C scan algorithm? So one, two. So I have to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10. सर ये हाफ है, इसके पहले इससे 3 गुना निकला है. So this is 0 and this is 199, right? And in between we have 18, 18, 47, then 50, 55, 70, 100, 112, 144, 187, 187. Okay, have I missed something? Pin. Have I missed something? Can I? 14, 7, 10, 11. So 0, 18, 47, 50, 55, 70, 100, 112, 144, 187. Okay, maybe. Yeah. Okay. So these are the things. Okay. So it starts from the, so it is given that it will start from cylinder 50. Okay. And here, so I'll be going to 47, from 18, from 0. So then from 0 in C scan, I'll be going to 199. Okay. Then I'll be coming back to 187, then 144. What's happening? Sorry. Wait a second. Okay. There's a problem maybe. So this is like this will happen. Okay. So correct answer is 395. Right? Okay. Now, okay. So yeah, Luke is the right answer. So which of the following these scheduling algorithm eliminates unnecessary stick operation and increase average response time? So this is the Luke algorithm. So Luke is basically similar to scan, okay, except for the difference that the disk count, in spite of going to the end of the disk, it only goes to the last request to be serviced. So in front of the head. Okay. So in C scan, basically what happens that it goes to the last of the 199. So in look, what will happen? It will go from here to here only. So this much space, this time will be saved in loop. So this is loop. Okay. So can you solve this question on loop? So we have 6, 10. So these are the requests. One. So you are starting from cylinder 22. Sorry, we're starting from cylinder 23 and starting from the current head position 23. What is the total distance? So using loop algorithm. Can you try once and tell? So in loop, basically loop is same as C scan, but it will not go to the end of the disk. It will go up to this one, and the last serviced last request which was asked to serve. Okay. You are right, Diksha. It is 139. Okay, so the correct answer is 139. Okay, so why can you tell? I am just writing the how it will be solved. 23, then it will be go to 15, then 12, then 10, then 6, 34, 44, 45, 54, then 73, then 97. You can see the difference that here from, okay, 97, oh, I have one left, 110, 10, 128. Yeah. Okay, so 23 was the first one. Okay, so from 23 it goes to, oh sorry, 16 was the 6 was the first one. Okay, and from 6. It was going to 34. 34. Yeah, fine. So yeah, so here also Odisha is right. So we have, so 233 is the right answer because we will be going from 23, 15, then we'll be moving to 12, 10. So this is the C look. 12, 10, 6, 128, 1110, 97, 73, 54, then 45, then 44, then 34. Okay, so total 233 is the correct answer. So can I answer this? Yes, so the answer is all of the above. So all of them is the correct answer. Okay. So data structure is used to improve the performance of the data storage system, improve the reliability of the data storage system, and make the data storage system fault tolerance. Yes, ls is the command too. So it is a very useful command. ls, and then ls minus l. This mean list and this mean list all. So, hi Satta. So I'll be coming to your question at the end of the class. Okay. So we'll be solving the question you have entered. Yeah. So right answer is home directory. Okay. So you have just one question left. So after this, we'll be solving this one. Yeah. This is true. Hierarchical organizations of the files and folders. Okay. हो गया। इससे 3 गुना निकला है। Okay. Okay. So first, let's try to solve the Satya's question. Sorry. This the answer is A. Reduce to need for non-directory traversal during the file access. Okay. So yeah. So first, try to answer this question that in a paging system, it takes 30 nanosecond to search in TLB. Fine. Then 50 nanosecond to search for access to the memory. 50 nanosecond for memory. Okay. Then it says, yeah, TLB hit ratio 85%. TLB hit 85%. Then memory access time. Yeah. Okay. So I have solved this kind of question. Yeah. How we will find the effective memory access time? So you will find the memory access time by, yeah, right. Effective memory access time will be time that is need to convert virtual address to physical address plus access byte from physical address. Okay. So what is this time? So this is t plus 1 minus pt into k into m. Okay. Plus memory access time plus page fault into page access time. Okay. So what is our t? So is there any t? So how many levels of paging we have? We have no levels of paging. So this is 0 plus 85 was, yeah. So it will be 85. So it will be 0.15 into k into m. So we have no k. K is 1 only, and 150 nanosecond. Yeah. So regular memory access take 15 nanosecond. Okay. Hmm. Now we have m plus, so m is 50 plus f into pt into ps. So it will be so 50 memory address is TLB hit ratio, which is yeah. So okay, yeah. So we have to add this before adding this one. TLB access plus main memory. Okay. Plus we have TLB miss. So if I miss the TLB, then what I have to do? I have to add TLB access time, because whenever I will miss, I of course I have searched the TLB, so that's why. Okay, so if I hit the TLB, so my memory is present in the TLB, then I will go to TLB and I will go to main memory. So this is the thing. If I miss it, then I have already searched in TLB. That's why TLB access time plus 2 into main memory access time. Okay, why 2 into? Because uh, you have searched the main memory two times. Okay, got it. So this is the case. And also, yeah, so this is the case. So if I solve this, I'll get TLB hit ratio is 0.85 into 30 plus 50. Okay, then I have 0.15 into 30, which is TLB for 2 into main memory. Yeah, so this is the case. So now what will I have? 0.85 into 80 plus 0.15 into 130. So it will be, if I calculate this, this will be 0.68 plus, and this will be 19.5, which will be 87.5 nanosecond. Okay. So I hope this is clear to you. Maybe this is wrong. Maybe yeah, 87.5 should be the correct answer. This my 83 is given because they have not calculated this. They have not they forget to enter these two. So if you don't calculate these two, then I think we'll be getting 80 only. Okay, so 0.15 into 80. So it will be 0.15, 0.15 into 80, which will be 12. 12, so 68 plus 80. You are saying 83 is given. No, no. Don't know, but 87.5 is the correct answer. Okay, now another question is our next question was about a thing that, yeah. So a computer system with 512 bytes of main memory runs a process with four segments of unequal sizes. The process is loaded in the main memory using the following segment table. Yeah, a segment table is given. The computer system uses 11-bit addresses. What is the physical address corresponding to the logical address? Okay, okay. So to find the physical address corresponding to the logical address in a system with segmentation, we need to break down this 11-bit logical address into the so how it is given that our logical address is given 1100, then 0001, then 101. So I am solving the question Diksha has posted in the chat box. Okay, so this is the thing. Yeah, I think I have written it correctly. 11000001. Yeah, I have written it correctly. Okay, so first few bit will represent the, maybe some bit will represent the segment number, then remaining bit will be offset. Okay, so we have how many segments are there? We have four segment of unequal size. It is given in the question, you can see it. Four segment with unequal size, right? Okay, so I can assume that 0 to 3, I numbered this from 0 to 3. So here I assume that first 2 bit is our segment number 3. So first, why first 2 bit? Because using 2 bit, you can represent it 0, 1, 2, 3. Okay, so that's why 2 bit is sufficient. So that's why first 2 bit is for 3 segment, for 4 segment. Okay, so yeah, then we have remaining 9 bit. So so what are the remaining? So first 2 bit first 2 bit is this one. Okay, and remaining 9 bit is basically I am talking about this one. Okay, got it? So this 9 bit, which is 00001 so here offset is equal to 2 cube plus 0 1 2 3. So 2 cube plus 2 square plus 2 to the power 1, which is equal to 13. You can see it here. So this is position 3, 2, 1, 0. So 2 is present at position 3, 2 and 0. So that's why 2 to the power 3, 2 to the power 2, 2 to the power 1, which is 13. So it is our segment number. Okay. Now, from this segment table, we see that, so we have a segment table given. Okay, so we using the segment number, a base address in decimal and length in bytes. Okay, so we have to validate it. So from the segment table, we see segment 3 has a base address 180. Segment 3, the last row, see the last row. From segment table given in the question, we can see that the last row, we have 3, 180, 100. Okay, so this is segment number, base address and length. Got it? Fine. So offset 13 is valid. So what I get from here, that offset 13 is a valid one. Okay, which is the because it is less than 13 is less than 100. So length was 100, so we have to validate it. And so how I will calculate the physical address? The physical address is calculated by adding the offset and to the base address. Okay, so physical address is equal to base address plus offset, which is 180 plus 30, which is 193. Okay, so if I convert 193 into binary, okay, it will be 1 1. So it will be 1 1 5 0 and 1 1. Okay, so yeah, so this will be the correct answer, 1 1 triple 0 0 0 1. And here we have, yeah. Hmm. So this has 3 4 5 6 7 8. So this has 8 bit. Okay, but you can see here that this has 8 bit. 8 bit we have, but in our physical address, the segment is given as, yeah, the, yeah, so so in, so we have to see, how can I say, yeah, so we have to represent it in the 9 bit. So for 9 bit, add 0 at the beginning. Okay, so this will be the correct answer. So D is the correct answer. Okay, yeah, so this will be the answer. Okay, fine. So in my calculation, this will be the answer. Okay, so thank you everyone for joining.